Welcome to this production and operations management tutorial video on productivity. In this video, we will show you how to compute single-factor productivity and multi-factor productivity. When computing productivity, whether it be single-factor productivity or multi-factor productivity, it's important to remember the basic formula, and that is productivity is equal to the value of the outputs divided by the cost or the value of the inputs. Now, the measurements for the value may be very different. It may be in units, it may be in time, it may be in dollars, and so you have to be careful to really make sure you know what it is you are measuring. Now, for this first example, we'll take it right out of the course pack, and we're looking at the BYU-Idaho example where in 2005, these are not official numbers, I just kind of pulled them out of thin air, but we had 720 faculty in 2005, and then we're saying we had 800 in 2010. That represents an increase of 11%. Total number of students that were served throughout the year, 18,000 in 2005, 26,000 in 2010. So to measure the productivity for each of these two periods, or snapshots, we would look at, again, this very simple formula. So the value of the output is our students. So we have, it's the value of the outputs divided by the cost of the inputs, or the value of the inputs. And so we just simply have the output being students divided by faculty. And so what that says is we, with each one faculty member, we're able to serve 25 students. We do the same thing with the 2010 data, and we see that we're able to serve more students per faculty member. And so this is the measure of productivity: 25 students per faculty in 2005, 32.5 students per faculty member in 2010. To see how much we increased productivity, we look at this formula here. The change in productivity is equal to the new productivity divided by the old productivity minus 1. So we will open up a parentheses. The new productivity is 32.5 divided by the old productivity of 25, close parentheses, and minus 1. And here we get a 30% increase in productivity. So that means for each faculty member by 2010 as compared to 2005, we were able to serve 30% more students. We're now going to move on to computing multi-factor productivity. Now, it may seem a little more complicated than it is, but if you keep focused on the basic equation for productivity, value of outputs divided by the value of the inputs, or the cost of the inputs, you should be fine. In this case, our outputs are measured in number of shirts produced, not the dollar value of the shirts, but just simply the units. But our inputs are measured in the dollar value of those units. And so to compute this, we would simply take the value of the outputs, and again, we're just talking in terms of units, and we divide that by the sum of the value of the inputs. And so we'll take the sum of labor, materials, and overhead, and that gives us 0.154. What that tells us is for every dollar of input, we're able to produce 0.154 shirts. So that means what it would take about $6 of input to produce a shirt. In the next example, we have lowered the cost of labor by $500. And so now we can copy and paste, we'll just paste the formula for that same productivity equation. And we see that now, for every dollar of input, we're able to produce 0.167 shirts. And so we've increased our productivity. How much have we increased our productivity? Well, we just turn to that same old equation right here. Change productivity is equal to the new productivity divided by the old productivity. So again, we take the new productivity, 0.167, divided by the old productivity, minus 1. And that tells us we had an 8.3% increase in productivity. Now we're going to move on to another example for multi-factor productivity. Same numbers, except for this time we are assuming that our shirts sell for $15 each, and we had 1,000 shirts before, and so now we're going to measure the output in terms of the revenue, the value of the shirts or the outputs in terms of revenue. So we do the same equation as we did before, and output of $15,000, and divide that by the sum of the inputs, and that gives us 2.308. Now, since we're all values are in terms of dollars, then we could say here that for every dollar of input, we get $2.31 of output. You can copy that formula and paste it here again, and we'll just paste the formula. And as we increase the, decrease the labor cost by $500, now for every dollar of input, every dollar of input, yes, we are able to get $2.50 of output, an increase of 19 cents. And again, if we use our change in productivity formula, it's the new productivity divided by the old productivity minus 1, and we get, again, that 8.3% increase in productivity. Well, these are some very simple examples on how to compute productivity. In the homework, they're a little more complicated. You just have to remember, again, the basic formula, and to convert all of the inputs, if you have multiple inputs, to convert them to dollars so that you're speaking the same language in terms of value, and then you'll be fine.